Hello everybody, welcome to this new lecture on double dispatch. This is a complement to the previous lecture on stone, paper, scissors. Here we will see how we can add a die and DieHandle. So the goal of the lecture, this is to show how conditional can be turned into extensible design using message and double dispatch. This is typically the case for a more complex situation with the visitor pattern. So let's see. In the previous MOOC, we didn't add the complete lecture in this MOOC. We could have a DieHandle that would contain die. So here, for example, I have a DieHandle that contains a die with 6 faces and one with 10 faces. And then we could say to the DieHandle, okay, roll, and it will return here a number between 1 and 16. So this was an exercise in the previous MOOC. It was fun. We strongly suggest you to have a look. This is a 6-minute video, and then there is an exercise, so you should have a look. Now the question is that in this version, we could really write expression like that, like in the Dungeon Dragon books, where we could say, oh, you know, I have 2 dice of 20 faces plus 3 dice of 10 faces. And the plus would create a handle. And like that, what we could do is that we could take the Dungeon Dragon books and just write this expression, put in parentheses and write roll, and then like that we could just play our games following what is written in the book. So that was what we did before, and now in this lecture we will change the plus here, because before we were doing 2D, so this means that this 2D was returning a DieHandle, and the plus was always between DieHandles. And you will see that we want to have it between dice. So for example, we added new requirements on the previous exercise. So here we said, oh, you know, why do we limit ourselves plus only with DieHandle? Why we cannot say that I have a die with 6 faces and I will add another die with 6 faces, and this guy should return me a DieHandle with 2 dice. And then in that case, I can send the message roll to this guy. What you see is that here, the plus suddenly is managing also dice, and before it was just DieHandle. Then we added, we can turn this requirement as a test, and this is easy, you know, this is the same. And we said, okay, this means that we will have a DieHandle that have 2 dice. Now the requirement 2 is that why we limit ourselves? We want to be able to send the message plus to a DieHandle with as argument a die, or the inverse. Why we cannot just send the message plus to a die with a DieHandle as argument? And this is what we will do in this lecture. You see, we can turn also this new requirement as a test. We do it like that. We really strongly suggest that you do the exercise during this MOOC, and then you know if you succeed or not when your tests are passing. So a possible solution, this is with conditions. Here what I am doing is that I'm creating on the die class a message plus with an element, an argument that is either a die or a DieHandle. And then what do? I just create a new DieHandle, and I add the receiver, and then after I do I fall back on the previous case. So this means that before I knew that if I have a DieHandle plus a DieHandle, I know that it was returning a DieHandle. So here, basically, this is what I am doing. I said, oh, you know, I create a DieHandle, except that it does not work. Because if I specify a die, I didn't convert it. So it could nearly work, but it was not the case. So what I have to do, in fact, here, I wrote it the traditional way. You know, I said, aha, okay. So on DieHandle, when I have a plus, I will check that my argument is a DieHandle. If this is the case, I create a handle. I go over all the die. I add them to this new handle. And then now I know that my argument is a DieHandle, so I can get its dies and then add them to the handle. And I do the same in the other branch. This is not really nice, but this is what we can do. It works for two cases, but it does not really scale. So of course, in our little toy example, we have only die and DieHandle. In reality, when we will work with a document, for example, or with trees that represent programs, we have 35 nodes. So, and not 2. So this means that you see the size of the condition that can be really intractable, or it can be, but it leads to design that are really brittle. So typically in Pillar, the system that is used to create the slides that you are watching, we have list, figure, paragraph, section, title, text, reference, two kinds of list, code block. We don't have a plus, just a plus. We have rendering test, generating HTML, generating LaTeX, and so on. So this means that for each of those guys, we have to repeat this. We would have to repeat this condition for something like 35 different nodes. And when you do analysis of languages, for example, what you should notice is that in Java, you have around 70 nodes, in C++, 180. So it does not really scale. That's why the visitor pattern is working well. And this is based on what you will be learning in this lecture. So now the solution. A good solution, or that we want to show in this lecture, is based on the first lecture of this MOOC that says that sending a message is making a choice. In fact, the system will select the correct method given the receiver. So this means that to select a method based on the receiver and the argument, because this is what we want to have here. Here, if we step back, we want to have a DieHandle plus a die working. We want to have a die plus a DieHandle that is working, or we want to have a DieHandle plus a DieHandle, or a die plus a die. All these solutions should work. So this means that basically, conceptually, this is like if we would have different versions of plus that are based on the different, the receiver and the argument, the configuration. You see? So double dispatch is made to really select the correct methods based on the receiver and the argument. So the sketch of a solution. In fact, when we want to add two elements, a die or a DieHandle, we will tell the argument to add itself to the receiver. Because the receiver, we know who is it. What we don't know, this is the argument. So basically, we just have to send a message to the argument, and the argument will have to have multiple methods to handle this case. And this is a bit the same like what we did in the stone, paper, scissors. Here we said, okay, when the receiver is a die, it will tell the argument to add itself to a die. When the receiver is a DieHandle, it will tell its argument to add itself to a DieHandle. Let's see how we do it. It's a first try. It will not really work, but let's try. So the first thing that we can do to add the plus in the die class, this is we create a DieHandle, we add self, and we add a die. It does not work because this guy can be a DieHandle, but let's see. Let's start like that. So you see, this is what I said, a die here can be a dice or a DieHandle, like in this code. Here the plus, this is a DieHandle, so it does not work. But we can do better. So now we can introduce sum with a die. We said, okay, let's make sure that we know how to add a die and a die. So to add a die and a die, this is what we did before. We just create a die handle, we add a die, and we add the parameters. And that this guy return a die handle, so we are happy with this one. And now what we can just say, we can say, oh, you know, the plus, we revise it, and we said, okay, we send to the argument the message sum with die, passing self as argument, because we know, because we are in the die class, so self is a die. What we don't know, this is what is this guy. So this guy can be either a die or a die handle, so we just send this message. And now this case, for example, let's look at it graphically. This case is working for only one case, this one. We have a die plus a die, so we send the message here, plus knows that this guy is 10, for example, and this one will be 6. So we know it, and then it means that it will execute because we will send sum with die to a die. So we look inside the class die. Okay, we have sum with die. This is this one. So this is okay. It works. So now the key question, this is how can we make it work so that we have a die plus a die handle. Because with that case, here it will not work because it will send the message dice. It will send the message sum with die to that guy. So in fact, what we should do is that we should implement these methods. To support this, this message, when the argument is not a die but a die handle, what do? We define sum with die in a die handle. So now this is clear. We know that we have as argument a die, so we create a die handle. We will copy all the dice of the receiver inside this new handle, and then at the end we just add the die to the new handle because this is done, and we know that this is this one, so we are done. So let's look at it now graphically. So imagine I have a die here and I have a die handle. I send the message plus. Now it starts to be interesting. So I send the message plus. This is a die, so I look for the methods in this class. Okay, I have the message plus. So this is this method that is executed. So self, this is a die 6. Diceable, this is this guy. So I send the message sum to an instance of die handle. So I will look for these methods. Basically, this is this method here that will be executed. And I do the correct things and I return it. So you see, so it worked well when I have a die as argument, as receiver, sorry, and as argument I can have a die or a die handle. So what we see is that we have two kinds of messages. We have the plus that is selecting first a class, and then sum with die that is selecting the message that will be executed on the argument. Okay, now we want our solution to also accept receiver as die handle. What should we do? We will do the same for die handle. In fact, this is just the repetition on another case. So what we will do is that we define the method plus on the class die handle, and now we know we will set sum with handle because we are in the class handle and we specify self. In fact, we do exactly the same as what we did on the die class, but we do it on the die handle class, and then we will have the support for, we will define this method on two classes, one for die and one for die handle. And like that, we will be able to handle all the case. We will be able, in this particular case, to handle the sum of two die handles or one die handle and a die. Let's look at it. So, on the class die handle, to sum a die handle, this is easy. I create a new die handle. I go over all the die that are in the receiver. I add them into this new die handle. And then I take the argument, I take the dice of the argument, and I do the same and I return the handle. By the way, this is a functional design. Huh? So this means that if you have a die handle with plus a die handle, So if let's say this is 10, 10, 10, and here this is 6 and 10, when I do plus, I will return a new DieHandle with 10, 6, 10, 10, 10. So that's why I create this new DieHandle. Now on the class die, I will define the sum with handles, and now I know that I have a DieHandle, so I will create a DieHandle. I will sum the DieHandle, the die of the DieHandle into this new handle, and I add self because I am on the class die, so I just add a new die. So now you have the complete solution. Here we manage the 4 case. Let's play a bit with that. If I have a DieHandle plus a die, what's happened? First, the plus will select in the class DieHandle. So this means that this is this one that will be selected. So I will execute first this case, and the argument here is a die. So this means that I will have a die sum with handle. So in that case, I will go here. I will go here because I have a diceable. So I don't know if this is a die or DieHandle, but in my case here, I know that this is a die. So suddenly I go here, and then I execute this code. Now let's do another one. So imagine that you have a DieHandle plus a DieHandle. That's easy. The plus is what? This is this one. We go here. This argument in diceable is this guy. So I will do sum with handle on the DieHandle class. So sum with handle on the DieHandle class. This is this one. And we do that. Now let's continue. So imagine that we have a die plus a die. So if I have a die plus a die, the plus is which one? This is this one. So it will select this one. I will look. So this is the method. I know that die, this is the argument here. So that will be sum with die on a die. Sum with die on a die. This is this method. Now, what do we have that is missing? We have a die plus a DieHandle. Okay, so let's erase that. So a die, the plus is what? This is sent to a die, so this will be this one again. Now I know that this is a DieHandle. So here I will have a DieHandle. So I will send sum with die to a DieHandle, sum to a DieHandle. So the same handle, sum with die. So this means I will jump here. What you see is that we have a first dispatch, the plus, that selects this plus or this plus. Then we have a second dispatch here and there that will select this version of sum with die or this version of sum with handle. Double dispatch. So the 2 here and 2 here. So what you see is that each time you send a message plus, the system selected the correct method on each class, and then after internally sending another message to the argument was selecting the correct methods in the different classes. In fact, if we step back, we apply 2 times the same principle. We send a message and the system selected the correct method for me. So sending a message to an argument was a way to select again between different methods on different classes. So as a conclusion, double dispatch, sometimes it can be difficult to grasp. You have to try to do it, to follow what's happened, do the exercise, but this is really powerful. Sometimes you don't want to use it too much because it can be confusing, but you have certain cases like, for example, compilers or things like that, or document, or when you have a composite structure, you will see the composite pattern soon. A composite structure with a lot of nodes where you have to do special treatment for each of the nodes and you have to do different special treatment, then you will see that this is really a call for the design pattern. And the design pattern visitor, it is based on this double dispatch. And to understand really clearly the visitor design pattern, you have to understand double dispatch.